Module 4, Lesson 4, the relationship of division and subtraction. Quick look at our learning targets. We are continuing to explore the relationship between the operations, looking at specific and general situations. There may also be a little bit of comparing expressions, in particular focusing on when they are equivalent. Today's focus, I can show and explain the relationship of division and subtraction for specific and general situations. And just a quick note here, these are going to look just a little bit different than some of the other relationships that we've looked at. I'll do my best to not be too confusing. So first thing you need to do, build a tape diagram that has 20 squares, so use your hands-on manipulatives. Go ahead, pause the video and take care of that. When you're done, go ahead and unpause the video. So hopefully you built something that has 20 squares. Now go and move your manipulatives so that you have 4 equal sections. If you're doing this on paper, indicate how you would separate this into 4 equal sections. So here's my 20, and here I have moved them so that I can have 4 equal sections. If I were going to mark them in 4 equal sections, I would do groups of 5, 1, 2, 3, 4, 5. So there's 5, 1, 2, 3, 4, 5. There's 5 more, 1, 2, 3, 4, 5. There's 5 more, 1, 2, 3, 4, 5. So I would indicate in writing my 4 equal size sections. And how many squares are in each of the sections? Well, I just counted them off. We've got 5 in each section. So now stop and think, how could you write a number sentence to show what happened? Pause for a moment, jot that down. When you're ready, go ahead and unpause the video. So we had 20, we divided it into 4 sections. We put it into 4 parts. And in each of the sections we had 5. So go and put your squares back together so that you have your tape diagram with 20 squares. So we had separated them, put them back together. So if you were doing this on paper, you would undo those markings, those groups of 5. So slide everything back together. Now this time we are going to subtract 4 squares from the tape diagram. So we're going to take some away. Remember, we're looking at the relationship between division and subtraction. So take 4 squares off and write an expression to demonstrate what happened. Well, we had 20. We took away 4. So it would look like this. So you've got now less squares, 16 if you're doing this in your head, and subtract 4 more squares from your tape diagram, and change your expression to show what has happened. So we're still working with the same expression, but we're just going to continue it. We had 20, we took away 4, and now we've taken away 4 more. So now we've got this many squares. And if you haven't figured out, we're going to subtract 4 more squares from the tape diagram. So here's our new tape diagram. We've got 4 less. And you may have figured out we're going to change the expression to show what happened. Remember, we are continuing on the expression. So we had 20. We took away 4. We took away 4. And then we took away 4 more. So now we've got this many squares. And if you haven't guessed, we're going to subtract 4 more squares from the tape diagram. So now we have this many squares. And if you haven't figured it out, going to change the expression. We're going to add on to the expression to show what has happened. So we had 20. We've taken away 4, 4, 4, and 4. So what you'll notice here is we are showing what is happening as we are continuing to take away 4. So we've got 4 squares left, and we're going to take away 4 more now. And there's nothing here because we've taken all the squares away. and we need to indicate that with our expression. And at this point, we can evaluate out the expressions. So if we have 20 and we take away 4, we've got 16. And take away 4 more, and we've got 12. And take away 4 more, and we've got 8. And take away 4 more, and we have 4. And take away 4 more, and we have nothing left. We are at 0. So reflect here for a moment and ask yourself, what was the step-by-step process that we followed to find that the difference was 0? We say difference because it's a subtraction problem. What are we doing that is going to lead us to get to 0 here? And I already said it out loud, but here is a pictorial, I guess not pictorial, but here's what the number sentences look like. We subtracted 5 times. We subtracted 4 out 5 times, so the quotient would be 5. So 20 divided by 4 gives us 5. Now, it's important to recognize here that we didn't end up with 0. In some of the other expressions that we had been working with on other days, we would keep ending up with 0. Well, we subtracted out here and we actually found out 5. We found out the number of times that we subtracted out. So is there a relationship between these two expressions? 20 divided by 4 equals 5, and 20 subtracting 4 a whole bunch of times, specifically 5 of them, takes us to 0. Well, yeah, there is a relationship here. If we subtract the divisor, the number that we're dividing by, this 4, if we subtract it from the dividend, which is 20, and we do that 5 times, there'll be nothing left. We will have subtracted everything out. We subtracted 5 times. The quotient here tells us that we're going to be able to do it 5 times. So yes, this gives the same information as this, but this is answering the question of how many times do we have to subtract 4 to get to 0. That's the information that this particular quotient is providing. So let's take a look at a similar problem. 20 divided by 5 equals 4. And let's see if the quotient is the number of times that the divisor is subtracted from the dividend. Remember, we said we've got this much, and we're going to subtract 5, and our prediction is we're going to have to do that 4 times. So we are going to subtract our divisor, 5, from 20 until we get to 0. So we'll take 20, and we'll subtract 5, and that will give us 15. And we'll take 15 and subtract 5, and that will give us 10. And we'll take 10, and we'll subtract 5, and that'll give us 5. And we have 5, and we subtract 5, and that leaves us with 0. So how many times did we subtract out the 5? Our prediction was 4. Let's do a quick check here. We subtracted out 1, 2, 3, 4 times. So our prediction was correct. So what would our number sentence look like? Well, I just showed you one version of it. Just showed you this. And here is another way that we could write it. Except I think I got just a little bit overexcited, and I think I've got 1 too many 5s in there. Probably need to get rid of that, because we only subtracted out 5 4 times, not 5 times. I'll have to fix that. So what is the relationship between 20 divided by 5 equals 4 and 20 minus 5 minus 5 minus 5 minus 5 equals 0? Well, 20 divided by 5 equals 4 can be interpreted as subtracting 5 4 times. Or as it's written here, interpreted as subtracting 4 5s from 20. And we will end up with 0. So is the relationship always true? Is this something that works every time, or is it something magical about 20s, 5s, and 4s? So let's try to think about how can we prove that it is always true. Well, I want to step back here for a minute, and I want to review what are the meanings of division. So in other words, what are 2 things that the divisor can tell us. And we worked on these earlier this year. I think it was in Module 2, and we talked about partitive division and measurement division. Well, one of the meanings of the divisor is it tells us how many groups to make. Another meaning of the divisor is to tell us the size of the groups. So 20 divided by 5 can mean make 5 groups, or it can also mean make groups of 5. So in this problem, 12 divided by 6, pause for a moment, think about this. It could tell us the number of groups. It could say make 6 groups out of these 12 that we have. Or it could say make groups of 6 from 12. Now these would look differently. If we make 6 groups, that's 6 groups. Each group has 12. If I make groups of 6, they look different. They both have 12 in them, but how they are organized and arranged is not the same. All right, so here we're going to try and work on the general. So x is a number, and we're asking ourselves, what does 20 divided by x equals 5 mean? Well, stopping and thinking here, it says that we've got 20, and it means we're going to subtract x out 5 times. We don't know what x is, but we know that we're going to subtract it 5 times. So 20 is divided to make 5 groups, or that 5 x's can be subtracted from 20. So looking at this, we should be able to make a prediction. What is x going to be in this division sentence? If we are going to subtract out 5 of something and get to 0, what must we be subtracting? Well, we already know it's 4. Our brain screamed at us, it's 4. 20 divided by what is 5? It must be 4. So how can we show subtracting these x's from 20? How would we show this with a picture? Well, and I know this is a little small, but what they're showing here is that we've got 20 and that we're going to take x out 5 times. So there are 5 x's, 1, 2, 3, 4, 5. So we are going to take out 5 x's, and we're asking ourselves, how does this look? So we have 20 and we took away the first x, and we have 20 and we took away 2 x's, and we have 20 and we took away 3 x's, and 20 and we took away 4 x's, and 20 and we've taken away 5 x's, and you can see each time they have been removing the x's. And down here at the end, there are no x's left. So we have 20, and we're going to take x away 5 times, which is why there are 5 x's here, because we're taking them away 5 times. And the subtraction sentence? Well, here it is. 20, and we've taken the x's away 5 times. So if we put our 4 in here, because we predicted it would be 4, if we subtract 4 out 5 times, do we end up with 0? Well, yes it does. All right, so we're going to think here for a minute. What are 2 equations using numbers and letters that we can use to show the relationship of division and subtraction? So we're going to try and look at some general examples here. So one way is what we already looked at. 20 divided by x is equal to 5. We're going to take x out 5 times. Subtracting out x, how many times? 5 of them. And this is the problem we just looked at, and we just proved that it gets us to 0. Now here is a different way that we can look at it. 20 divided by x equals 5. So here we are looking at x is the number of times that 5 can be subtracted. So now we're going to change the meaning just a little bit. Now we're saying let's subtract 5, and x is the number of times that we can subtract 5. So we're going to subtract 5, and we're going to subtract it 4 times. So we have flipped the meanings here. Earlier we were looking and saying this tells us how many times to subtract. Now we're looking and saying this tells us what to subtract, and we are counting how many times to subtract. And how many times is 5 subtracted from 20? Well, we know that it's 4. And how could we draw a tape diagram to show how many times 5 is subtracted from 20? Well, here is our tape diagram. And we know that each of these will be 5. And we are showing that we are subtracting 5 off over and over again and counting how many times we can subtract the 5. So we subtracted 5 from 20 4 times. And would x equal 4? Is 20 divided by 4 equal to 5? Well, of course it is. We've done this problem about 5 different ways today. So what two operations are we relating in the 2 examples that we have created? We are comparing division and subtraction. We are looking at the relationship. This 5 can have 2 different meanings. It can be how many times we subtract x, so subtract out x 5 times. Or it can tell us that we are going to subtract 5, and x is how many times to subtract it. So looking at your exercises here, and I'm not going to do all of these, I'll quickly show you an example, but notice right here the divisor is going to tell us the size of the groups. So this number right here tells us how big the groups are, and this should tell us how many times we are going to subtract it. So the divisor here is going to be x, and we are going to subtract x times. So 12 minus x minus x minus x minus x. The divisor tells me the size of the group. The quotient tells me how many times. So our tape diagram shows us that we should have 4 x's because we're going to subtract it 4 times. And if I take 12 and I subtract x out 4 times, I'm going to find out that x is 3. 12 divided by 3 gives me 4. So go ahead and pause and complete 2, 3, and 4, thinking your way through them. Think about the expressions and number sentences that you would write. Might save you a little bit of space if you were to actually write your expression over here. That leaves you a little more room for your tape diagrams over here. So go ahead and complete that problem set there, exercise 1. Oops, sorry about that. All right, looking at the second part of exercise 1, the divisor is going to show us how many groups to make. So we have x number of groups, and each of the groups is going to be 4. So as we write out the expression on this, it's going to look a little bit different. We're going to take 12, and we are subtracting 4 until we get to 0. And it shows us that we subtracted out 3 times. So we've got our 12 here, and we're going to take out 4 3 times. So our x is equal to 3. So once again, on this example, the quotient is going to tell us what we're subtracting, and we have to subtract until we reach 0, and x is going to tell us how many times to subtract. So go ahead and take a moment and finish the rest of these problems. All right, so if 12 divided by x is equal to 3, how many times would x have to be subtracted from 12 in order for the answer to be 0? they're asking here how many times do we have to subtract this, and the quotient provides that information. So we are going to have to subtract 3 times. So 12, we're going to take away x, we're going to take away x, and we're going to take away x. And we would find out that x is going to be equal to 4. So here we have an example looking at repeated subtraction. We need a division sentence for this repeated subtraction. And what would the value of f be? Well, we've got 36, and we are going to take away f, and we're going to take it away 4 times. So 36 divided by 9 would be equal to 4. And we could draw a tape diagram here and quickly show we've got 36, and we are going to subtract f out 4 times. So I'm going to be making 4 groups out of that 36. So 36 divided by 4 gives me a 9. So here we have 24 divided by b is equal to 12. And which number are we going to subtract 12 times? So in other words, we're doing 24, and we're going to subtract b 12 times. And no, I'm not going to write them all out, but we'd keep subtracting. So we have the 24, and we're going to subtract out 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Going to subtract out 12 times, each one of these being b. So 24 is going to be split into 12 pieces, and we are going to find out that b would be equal to 2. All right, so a quick look at the closing here. So we've got some circles, and we're going to put one operation in each of the circles, and we're going to try and meet the requirements of the graphic organizer. So this operation here has to be a repeat of this one. And this operation here has to be the inverse of this operation here. They go back and forth this way. And this operation here has to be a repeat of this operation here. And these two have to be inverses. So let's think our way through this here for a minute. So in the upper left hand corner, we're going to put the addition symbol. And now we need to start thinking to ourselves, okay, what is the inverse of addition? Looking at this section right here. What is the inverse of addition? Well, hopefully your brain screamed at you. The word inverse means opposite. And hopefully your brain said, well, the opposite of addition is subtraction. So we would put that in the upper right-hand corner, because subtraction is the opposite of addition. Now, repeated subtraction. So we've worked our way from addition to subtraction, and now we're looking and saying, all right, we want to go from subtraction to whatever this is. Which operation is repeated subtraction? So subtracting over and over again. And that's what we worked on today. That would be division. Division is our repeated subtraction. So that leaves one square left, and of course at this point we're guessing that it's probably, oh, that should say in the lower right-hand corner. My apologies for that. So what operation is the inverse of division? And you're looking and saying, well, it's obvious because the only operation we haven't used is multiplication. Okay, that's great. So we've got multiplication, which we know can be represented a lot of different ways. So, but now we want to check. We want to ask ourselves, is multiplication the repeat of the addition? Because we have to check it this way. Well, we've worked this week and we found that multiplication is repeated addition. We know that multiplication and division are inverse operations. They're opposites of each other. We know that division is repeated subtraction. And we know that addition and subtraction are opposites of each other. All right, so taking a look at the I can statements here. Can you show and explain the relationship of division and subtraction for specific and general situations? I know this lesson was a little different than the other ones that we've worked on, a little more thinking that goes into it. If you're not comfortable, go back through, watch the video again, make up your own examples, try it out, see how it works. Taking a look at our learning targets here, showing and explaining the relationship between operations for specific and general situations. We've now worked through all 4 operations: addition, subtraction, multiplication, and division. We have also worked a bit on comparing, looking and saying, when are things equal? So that concludes Module 4, Lesson 4. Go ahead and work on your problem set. Rewatch the video if you need to. If you've got questions, make sure you touch base with your teacher.